Hello everyone, welcome back to my Chem Corner. In today's video, we're doing another question related to chemical bonding and molecular structure from the ncert textbook. So we're moving on to question number 4.2. Now the question reads, write the Lewis dot symbols for atoms of the following elements: magnesium, sodium, boron, oxygen, nitrogen, and bromine. So before we move into drawing the Lewis dot symbol, it's important to know what it means. So your Lewis dot symbol or the Lewis structure is basically talking about a diagram where you're representing number of valence electrons in an atom. So by valence electrons, I mean the outermost electrons in an orbital. All right. So before we draw the Lewis structure, for those of you who are really struggling in drawing a Lewis structure, it's important that you know certain things before you draw it, so it becomes easier for you to get a correct Lewis structure in the end. First thing is you know what is the atomic number of that particular atom. Then you have to know the group they belong to, the group number, group 1, group 2, group 3, and so on. And then you should be able to write the electronic configuration. So you have three things to be taken care of. And from the electronic configuration, you will be able to identify the number of valence electron. So this is for those students who find drawing Lewis dot structure is a difficult thing. So for them, these three things. Otherwise, for those who are really good in drawing the Lewis dot structure, group number alone will help you identify it. So moving on to the first element that is mentioned in the question, I'm talking about magnesium. Now, the atomic number of magnesium is 12 and the atom belongs to group 2. So now from here, you know the atomic number, you're going to write what is the electronic configuration. Now in one of the videos I had explained how to write the electronic configuration using the off-Bohr principle. This makes it easier for you. So I'm not going to explain this in detail. We have already done this in one of the videos before. So writing down the electronic configuration for magnesium, it is 1s2, 2s2, 2p6, 3s2. So from the electronic configuration, it is important for you to identify the valence orbital. Valence orbital is those orbital into which the electron last entered into, or the orbital which has the highest principal quantum number. These are the principal quantum numbers. So the one that has the highest principal quantum number is 3s and it has number 2 electrons. So that means my number of valence electrons are 2. Therefore, I will write the symbol and just put 2 dots. Now this is going to be the Lewis structure for magnesium. Alright. Now moving on to the next element, which is sodium. Sodium atomic number is 11 and it belongs to group 1. So here when you have the group number, from the group number we can easily identify the number of valence electrons. So if the group number is 1, that means the element has 1 valence electron. 1 valence electron. So when I write, it's going to be sodium with just 1 dot. So for those who are learning it along with the electronic configuration, sodium electronic configuration is 1s2, 2s2, 2p6 and 3s1. So when your highest principal quantum state is 3, it has only 1 electron. Therefore you put 1 dot. Now the next element is boron. Alright, boron atomic number is 5 and it belongs to group 13. So here in this element, the electronic configuration is 1s2, 2s2 and 2p1. So if you look at this, the valence orbitals are the one with the highest principal quantum number. I have two of it, 2s2 and 2p1. In 2s I have 2 electrons and in 2p I have only 1 electron. So therefore this is going to be 2 plus 1 in total 3. So I will write the symbol of boron and just put 3 dots. Alright, so that means I have, it belongs to group number 13. That means I will have 3 valence electrons. Okay, that is about boron. Now moving on to oxygen. So in oxygen, the atomic number is 8 and the element belongs to group 16. So just by looking at the group, you will know that it will have 6 valence electrons. Now if you want to follow the electronic configuration, it is 1s2, 2s2, 2p4. So here also if you see, the principal quantum number which is the highest is 2. That means you have 2 different orbitals here. You have 2 electrons in 2s and you have 4 electrons in 2p. When I add them up, it makes a total of 6 valence electrons. So whether you do by electronic configuration or you look at the group number and you write, you should get the same number of valence electrons. So that means I'm going to put a total of 6 dots around oxygen. So I'll put 1, 2, 3, 4, 5 and 6. Alright, now this is going to be the Lewis structure for oxygen. Now the next one is nitrogen. Nitrogen has an atomic number of 7. It belongs to group 15. Now by 15 we know that it is 5 valence electrons. Alright, now when there is 5 valence electrons, when you write the electronic configuration of nitrogen, it is 1s2, 2s2 and 2p3. So here if you see, for nitrogen as well, you will find it has 2 orbitals whose principal quantum number is 2. So the 2s has 2 electrons and 2p has 3 electrons. So this will give me a total of 5 valence electrons. That means nitrogen, you have to put 5 dots around it like this. Now that is going to be the Lewis symbol for nitrogen. And the last one being bromine. Bromine atomic number is 35. It's a huge atomic number, right? Now this is present in group 17. 17 means it has 7 valence electrons. So obviously in an exam you will not have that much of time to really think and spend to write the electronic configuration of certain elements whose atomic number is bigger. That's why I gave you the hint of writing a Lewis symbol using group number. So when you have 7 valence electrons, you have to use 7 dots around it. So I have 2, 3, 4, 5, 6 and 7. So this is going to be how you're going to approach Lewis symbol by knowing the atomic number first. Then you can know the group number. Then you know how to write down the electronic configuration. And lastly, you know how to calculate or find out the number of valence electrons by looking at the valence orbitals. With this, it should be easier for you to write down Lewis symbol for any given element.